Hey all, welcome back again. This is our Unit 4 Periodic Table of Elements video. Let's get right into it. All right, the periodic table. It first was developed by Dmitry Mendeleev, and what he did was, by the way, write his name down. He shows up. He is the father of the periodic table, so if you forget, I'm going to put it right here. Well, if I can get my pen working, of course, every time I do this, something happens to my pen. Okay, we're going to pause, come right back. All right, let me try. We'll just try this again. He is the father of the periodic table. Okay, so basically what he did is he came up with a system. It wasn't as elaborate as what we have today, but it was organizing the elements based on their masses. So he did it by mass. And then Moseley came along, Henry Moseley, and he did it by atomic number. So when Dmitry started it, all we had really was mass. We didn't know a whole lot about the atom at the time, and then by the time Moseley came around, we had more of the atomic number and the mass. Okay, so the periodic table is arranged in very specific order for very specific reasons. So let's get started first. We kind of talked about this already. We have vertical columns called groups. Okay, make sure you're copying this down if you're not sure. Okay, horizontal is the periods. We also called those the main energy levels. That's an N, energy levels. Okay, so our groups. This gives us our valence electrons. Remember that? Okay. So why are they in this? Why are they in groups? Why did Moseley put them in groups? Remember, where Mendeleev is the father of the periodic table. Moseley took ideas and ran with it. So if you look at each group, what do you see? Well, when you look at it closer, each atom has the same number of electrons in the outermost shell. So that's the key right there. That's where we get our valence electrons. Remember, valence electrons are your outer shell. So here's an example. So group 1, this is group 2. Sorry, group 2 has 2 electrons in the outer shell. If you remember, right here we have the second. Sorry. This is 2, 3, 4, 5, 6, and 7 energy levels. So it doesn't matter where you go. When you get on the energy level 7, you'll end up with 2 on the outer shell. Right now we're looking at these 2 right here. Beryllium has 4, 2 on the inside, 2 on the outside. Here, magnesium has 12. There's 2, 8, and then there's 2 more. Something we didn't talk about too much in the last unit was Bohr's model. It goes 2, 8, 8, 18. Okay, so keep that in mind. If you ever see a Bohr's model, that's where the 8 and the outer shell and stuff comes from. Okay, problem with the Bohr model, like I said, is this 18 right here. All right, the number of outer or valence electrons in an atom affects the way the atom bonds. I do want you to write all of these down. Okay, because we are going to start talking about bonding in the future units. So that's really what chemistry is about, is how things bond, how things react. Okay, so the number of outer valence electrons, here's that word again, valence electrons, determines what group it's in pretty much. The way an atom bonds determines many properties. Okay, so we're also going to, just because these valence electrons are working together in bonding, it also affects their properties. This is why they have similar properties in each group. So like group 1, I'll come back to that. If you look at an atom from each element in the period, what do you see? Well, we kind of talked about this before also. You see that each atom has the same number of electron shells. So if it's in energy level 2, then it'll have 2 shells. The first one with 2, and then the next one has 2. Okay, if it's in group 2, if it's in group 3, group 4, and so on. Okay. So here's an example. In period 4, all of these have 4 shells. 1, 2, 3, 4. So 1, 2, 3, 4. Here, 1, 2, 3, 4, and so on. Okay. So periods tell us how many shells. The groups tell us how many valence electrons. Okay. Each group has a distinct property, and this is where I was going back to before. The periodic table is also divided into groups based on properties. Okay. So for instance, group 1, and you notice hydrogen is not involved in group 1 because hydrogen is not a metal. Okay, where's my pen? Okay, so all of these right here in group 1 are alkali metals. We're going to label our periodic table in class soon. They are soft silvery colored metals. They are very, very reactive with water. And they increase with as you go down. So francium is stronger than lithium. Unfortunately, we don't have much francium doesn't stay around long enough to react with water too often. All right, so here's some examples. You can cut it like butter, the sodium and potassium. Okay, if you put it in water, it will react. Okay, so it goes from top to bottom. So go with that one. Okay, group 2. Group 2 are the alkaline earth metals. Okay, alkaline earth metals. That is magnesium and beryllium. They still react with water. They also are silvery and white metals, fairly reactive. They're found in rocks in the Earth's crust. Okay. Make sure you're writing this down. Sorry, I'll go back. Make sure you're writing all this down. Okay. Transition metals. That is that whole group in the middle, very middle. They're good conductors of electricity and they're malleable. They bend easily. This is where you're going to find a lot of your precious metals like gold, silver, platinum, things like that. Okay, so how many things can you think of that have transition metals in them? Well, hopefully you know coins, jewelry, airplanes, that kind of stuff. Okay, metalloids. I don't like the way this picture is too much, but we will be doing this on our periodic table. Your metalloids are on either side of that staircase that runs right along here. Okay, it will be boron. We're not going to do aluminum because aluminum is a metal. Silicon, germanium, arsenic, I want to say antimony, tellurium, polonium, and wait, I cannot remember what ST, but AT. We will go over these. They share properties with both metals and nonmetals. Okay, they're also called semiconductors. So you might see this on a test as well. Right here, semiconductors. My pen, I couldn't find it. Sorry. Okay, so what are they used in? Computers, any kind of electronics, your cell phones. Okay, and we did talk about cell phones. Okay, so now we have the nonmetals. Okay, if you notice now, hydrogen is now circled. Even though it's in group 1, it is only in group 1 because it has 1 valence electron. It is a non-metal. It is also a gas 90% of the time, if not more. Probably more than that, probably like 99% of the time. I don't think it's ever been anything but a gas. But I'm going to say that in case somebody finds it. Nonmetals are brittle. They do not conduct electricity. So if you notice, there's a smaller group of nonmetals right here. Okay. And you should be copying all of this down, even though I'm not circling it, but I am now. Okay. Halogens, they're also nonmetals, but that's these right here, group 17. Okay. These are your poisons. They're mostly poisonous gases, usually. So I think there's no, I take it back. They're not gases. Some are gases. I cannot remember which ones are not off the top of my head. Fairly reactive. They react with alkali metals a lot. Okay. I call these the pimps of the periodic table because they always want to take an electron, and you'll find that out when we start bonding. Okay. Next one. Okay, so chlorine, this is just some information if you want it. Don't have to write it down, but just know that chlorine gas was used as a chemical weapon during World War I and the Germans in World War II. And here's some of the effects that it did have on people. Oops, sorry. So you can kind of look over that if you want to. Stop the video and go on. Okay, here's the outside of it, I mean the rings of it. Okay. All right, we talked about these. These are going to be very important. These are our stable elements. Stable. Did I spell that right? I hope so. It's very late and I'm tired. Noble gases, they're unreactive. They're gases at room temperature. These are the ones that we do our noble gas configurations off of. They make signs. Yay. Okay. So jellyfish lamps made with noble gases. This is some artist that did this, Eric Ellenberg. I think it's pretty cool. Okay. So here's some colors of the noble gases and lamps. You can have that for your own information. We have two other series. We have an lanthanide series and an actinide series. These are the ones that we talked about in our cell phones. Okay. So periods of the periodic table and groups of the periodic table are going to be some very important parts that we look at. So again, chemical groups, we have alkali metals, alkaline earth metals, halogens, noble gases. Okay, so copy this down if you want it. We just kind of went over it, so you don't need to copy it again. There's 4 chemical families. We just talked about that as well. Metals, these are some properties. Metals, elements are usually solid at room temperature. Most elements are metals. Nonmetals, they're in the upper right-hand corner of the periodic table. Their chemical physical properties are different from metals, and metalloids kind of do both. So if you would please make sure you have this in your notes, okay? And I think we're going to stop there, and y'all have a good night.